Alright, so the next step here, guys, is cylinder head disassembly. Now, there's a couple of things you got to remember. There's valve keepers and valve locks in here, they call them. To break those loose, a lot of times what we want to do is, if the head is dirty and has a lot of varnish, we want to use solvent to clean that off. And also, to break these loose, you want to use a piston pin or a socket or something and a soft hammer. And you want to just put the socket, we don't want to hit the valve stem, we want to hit the retainer. So we want to take a socket and we just want to lightly tap on that to break that retainer loose. Now your head will be sitting on a set of headstands. You don't ever want to lay this on the bench like this and smack on that, because it can push the valve down, it can actually bend the valve. So you want this on a set of V-blocks or headstands or something when you do this. Once we get that done, we're going to take our valve spring compressor and we're going to remove the valve spring. So this goes on the valve itself, and we're going to run this down onto that valve, and we're just going to simply compress that spring. So we get this snug on here, we situate it. So then we just engage our tool. Now you'll notice that you'll feel it kind of pop loose there, especially with the bigger performance springs. So we're just going to take and run that in just far enough to get our keepers off. You don't want to over compress that spring, because there's a valve stem down here and you might damage that. So once you get your keepers out, there's the keepers, then we just let the compressor out and we very simply remove our springs and retainers. Now again, these are wear-mated parts, so it's really important that you keep these springs and retainers and so forth in order. So we're just going to line our springs, retainers up, keep them in order, and then of course the valve, you just remove the valve out of the cylinder head. Now if the valve doesn't want to come out of there, like sometimes they don't want to, this is getting tight, don't force that valve out. There actually can be a burr on this that we need to take care of. So you want to just take a regular file, and we want to take, you pull the valve out slightly like this, and we just want to take and file that burr off there. You notice I had a hard time getting that out. It just didn't want to come out. So I'm just going to file this slightly, just to knock off any burrs, because as the rocker arm rides on there, it can kind of mushroom the head of the valve sometimes. And of course, forcing that out through a valve guide can actually damage the valve guide. So once we get that off, you'll notice that it's still pretty tight. So I'm not going to force it. I'm going to file that until I get it out. Now that we've filed the burrs off, the valve comes out nice and easy. So there's your valve spring, and your keepers. And you'll notice that sometimes you have shims below here. You also, if they have shims on there, you want to keep those shims in order. Alright, so once we get the valve out, you guys, a couple things you need to check. Now, right here on the valve, between the face of the valve where it seats and the head of the valve, there's a flat surface here. That is what's known as the valve margin. We have to measure the width of that valve margin. The width of the valve margin is important because if it gets too thin as the valve wears or as we recondition the valves, it can actually cause the valve to overheat and burn and fail. So we want to measure our valve margin right there and make sure it's within specs. Another thing we want to do is we want to check our valve stem to guide clearance. Now, like anything else, the stem rides inside of a guide. Put it in backwards here. You can see there's a valve guide in there, and that valve stem is going to ride up and down. That valve guide that's in that cylinder head, it's like a little sleeve that valve rides in. So that valve rides up and down in there. Now that valve guide over time wears out. When this valve is going up and down, that's going to cause the valve to be very sloppy in there. It can actually let excessive oil run down the valve guide into the cylinders and cause the engine to smoke. And it also causes valve seating upset. So the valve is not seating straight. It can actually wobble in here, and it'll cause the valve to seat incorrectly, and that causes leakage past the valve. So we have to make sure that we check that valve guide and the valve stem for proper clearance. So the way we check the inside diameter of the valve guides, there's multiple ways. We have very small bore gauges that we use this, like most machine shops will use that. In our lab, we have a ball gauge or a transfer gauge or an inside small hole gauge. And what we're going to do is you just run this down till it's contracted and it's at its smaller size. We're going to put that right inside the valve guide. And we're just going to expand this gauge out until it gets snug in there. You don't want to over tighten this. Just expand it out till it just gets a little bit snug right there. And then we're going to pull that out. Now I can't read this by looking at it. I can't look at it and go, yeah, it's about this much. We have to transfer that reading to a micrometer. So we're going to take a 0 to 1 mic. Now you want to measure this opposite the split, or 90 degrees from the split, and we're just going to get on that and very gently mic the diameter of that. We're going to lock our mic and we're going to take that reading and we're going to compare it to the diameter of our valve. There is a clearance specified for this. It's usually between 1 to 3 thousandths depending on the head. But what we're also going to do is we're going to mic our valve stem here. We're going to take those two readings, we're going to subtract the difference, and the difference is going to be our clearance. Remember, the valve has to be able to move, so the guide is going to be slightly larger, but if it's too big, it can cause valve seating problems and oil consumption problems.